Magnetic field versus electromagnetic field. Below table helps you to understand both similarities and differences between magnetic field versus magnetic field. Electromagnetic field definition. Magnetic fields are the vector fields which specify the influence of magnetic force on the magnetic material, moving charges, and electric current. Electromagnetic fields are the combination of electric and magnetic fields propagating in the space in mutual perpendicular direction. Generation. The magnetic fields are generated by the charges under motion. Stationary charge can produce only electric field. By accelerating the charges, magnetic fields are produced, thus generating the electromagnetic fields. Speed. The speed of the magnetic field in vacuum is same as the speed of light. The electromagnetic fields always travel at the speed of light. Continuous property. Magnetic fields forms a wave-like pattern and are continuous, no discrete structure is possible. Electromagnetic fields are smooth and continuous and travel in wave-like manner, but in some circumstances, the electromagnetic field involved in transfer of energy is described using quantum theory carried by the packets of energy called quanta, which possess discrete structure of energy states. Interaction. The interaction of magnetic field is concerned with only the moving charges. If there are only stationary charges, then there will be no interaction of magnetic field. The magnetic field also well interacts with the magnetic material and electric current. Electromagnetic field itself produced due to the interaction of electric and magnetic field. They also interacts with the electric charges and current in the space. And also electromagnetic fields are concerned to interact with the magnetic material, but its effect is quite weak. Strength of the field. The strength of the magnetic field is due to the external current passing through the material, not because of the internal material property. The strength of the magnetic field is also known as the magnetic flux density, which corresponds to the magnetic field lines entering and leaving the area. The strength of the electromagnetic field is due to the amount electric current and voltage. Greater the voltage, then the electromagnetic field strength will be more. Application. The magnetic fields are widely used in the magnetic levitation, and compasses to determine the direction is one of the major applications of the magnetic field. Electromagnetic fields are widely used in the recording the data of static electricity, and the old television traces the electromagnetic field. Comparison table of magnetic Need to know facts. In an electromagnetic field, the force produced by electric field is much stronger than the force produced by the magnetic field. According to classical theory, the electromagnetic fields are concerned with the continuous transfer of energy between the 2 points forming the wave-like pattern. The continuous structure of the electromagnetic fields is hard to achieve at high frequency. According to the quantum mechanics, the discrete structure of the energy states of quanta in the electromagnetic field is given by E equals hf, where h is Planck, s constant, and f is the frequency of the wave. This describes that energy transfer is carried by the quanta with fixed frequency. The generation of energy in the electromagnetic field is due to the movement of the charged particles. The magnetic fields tend to exert force on a range of non-magnetic material, disturbing the motion of the outer atomic electrons of the material. In an electromagnetic field, the magnetic fields are distinguished into two relative vector fields named B and H field. H field represents the magnetic strength measured using the SI unit ampere/meter, it is the international system of notion. Whereas B field represents the magnetic flux density measured using Tesla. B and H fields differ from one another based on the magnetization. In vacuum, the relation between B and H field is given by B equals H0, where I0 is the vacuum permeability. The generation of magnetic field is not only due to the moving charges but also intrinsic magnetic moment of the elementary particles and their spin. Rotating magnetic fields are equipped in electric generator and motors. The interaction of magnetic field with electric devices gives the concept of magnetic circuits. In a static EM field, the electromagnetic field not varying with time, an observer can observe only electric or magnetic field because in a stationary electromagnetic field, the electromagnetic field overshadows magnetic field or vice versa. Frequently asked questions. What are the factors affecting the electromagnetic field? There are several factors affecting the electromagnetic field to propagate. They are: loop count, current size of the wire iron core. Why electric field is stronger than the magnetic field? The interaction of charges in the electromagnetic field with the electric and magnetic field describes the strength of both the fields. In an electromagnetic field, the existence of magnetic field is depending on the velocity of the charges. Even if the charge retards its motion, still the electric field exists. Thus at velocity v equals 0, the electric field will remain as it is. This makes the electric field is to be stronger. Can a magnetic field induce electric current? Magnetic fields are used to generate the electric current. When a coil consisting of wires is made to move around the changing magnetic field, the electrons tends to push itself in the wire. The current is induced at the conducting loop. Can we increase the strength of an electromagnetic field? Yes, the strength of the magnetic field can be varied manually. The strength of the magnetic field can be increased by following factors: increasing the number of turns of coil, increasing the current passing through the material, placing an iron cord near the coil. What is the major difference between electric and magnetic field? Though electric and magnetic field together forms the electromagnetic field due to changes, there are some major differences between them. The electric field can be exists if the charge is under motion or it is stationary state, while there will be no magnetic field if the charge is at stationary state. And also magnetic field has the capability of formation of closed loop while electric field cannot. Is it possible to have magnetic field without electric field? No, in general we cannot achieve magnetic field without electric field. The generation of magnetic field is associated with motion of the charges. Since a charge always carries electric field even when it is moving, so it is hard to achieve magnetic field alone. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.